Hey guys, so today I thought I was going to show you how to type Redux with TypeScript, so let's have a look at that. So pretty much I just have this idea that, hey, you know what, it could be useful for you to see how I do typing with Redux, and here it is. So I created this little project. I'm going to live code this because I did another video where I kind of just did that when I felt that, hey, it was appropriate, and some people really enjoyed that, so I'm just going to give it a bash again and do pretty much this live. Hopefully that's okay. And here you can see my dependencies and my dev dependencies. That's pretty much it, really. And I use Parcel for this video here because I don't want to go through the Webpack setup and all that stuff. That's a different video. But yeah, this is pretty much my application right now. So all it is a static little React application that is saying foo. Cool, right? So the first thing I want to do is that I want to wire this up to an app of some sort. So let's start by creating an app. Let's say that I create app.tsx and I do import React from React export const app, and that's just going to be a function that returns hello world, like so. And then I say app, like so. Come on now, import, thank you. And now it says hello world, amazing. And now after that, I want to wire this up to Redux. So I'm going to create a provider, which is the component that is responsible for wiring all of this good stuff up. Now that's going to complain because it wants a store, which is exactly what it's going to get. So let's create a store, store.ts. And we're going to say const, no, we're going to say export const store equals to create store. And that's going to complain as well because this wants a reducer. So we're going to do this. We're going to say reducers. And we're going to combine some reducers. And let's just make an empty one for now. Reducers, so now we have a store. There is nothing in it, but that's okay. Not that. Let's do this, and then let's do that. And there we are. And now we're wired up. And it's going to warn me because it doesn't have any valid reducers. And that's okay, because we're going to add that in. That's going to be the next thing. So now what we want is to create a reducer. And a reducer is just a function that is going to take the state of our application and return a new state. Sometimes it's going to be the whole state, sometimes it's going to, or rather it's going to be the same state, and sometimes it's going to be an updated state. Export const reducer, and that's going to take a state. We're just going to say any action .any, and then we're going to say switch, and we're going to say action.type. Let's just kill off this one for now, and we're going to say return state. That's going to be it. Const reducer is actually a function, a lambda function, like so. So now this is going to break. And the reason, well, no, it's not going to break because I need to add it in first, but then it's going to break, I promise you. App.reducer. Did I actually export that? Export const reducer. Yeah, do reducer. What? I don't want you to auto import it, you silly thing, but okay. I will just do it like an animal by hand, like so, and wear out my human fingers. So now it's going to be very upset with me because it says that app returned undefined during initialization. But I also want to do one more thing, and I want to just say app reducer because I usually, this is just me, you can be less lazy than I am. I usually just call it reducer in my function, my file like that, and then I rename it when I'm all up in the combine reducer space, because if you have many different modules on your Redux state, it's nice to not have name collisions and stuff like that. That's just how I roll. But now it's complaining, saying that, hey, it doesn't have an initial state, and I kind of go, oh, well, okay, let's do an init state then. So you just get off my back. Let's say that this is equal to init state, like so. And now it's not angry anymore. Everything is happy, everything is peachy. So Now that's that. Now let's create a container. TS like so, and then we're gonna say import app from app export const app, because I want to call my container app, but I also want my view component to be called app, so I'm just aliasing over that variable a little bit. And then I'm going to say compose, because I want Redux to help me compose together this little application component. So we're going to say component, and now that's all up in there. And then, well, actually I think I can do this with just this. I don't really have to do anything else, if I remember correctly. So now I don't want to grab the view component anymore. I just want to I want to grab the container. And hopefully this is going to make sense to you, because basically so all I've really done here, this is the thing that Redux pretty much does for you. This container component that I've created is just a higher order component that wraps the underlying component that is actually the thing that we're showing to our user, right? So this is just another component that is one level higher than the component that you see on the page. And that's the thing that I'm doing here. I'm just wrapping. Compose is just helping me wrap multiple layers of other components on top of this component. But this doesn't do anything. Like there's nothing around, like it's actually not showing me anything. I could do all kinds of magical stuff, but that's a different story. But now what I want to do is that I want to inject some information into my app component, because this hello world thing isn't really exciting, right? So I'm going to do an interface. I'm going to make one, and I'm going to call that iProps, and I'm going to say that I want to add a age, and that is going to be a number, and then I want to say on click, because that's going to be a function, and that's going to be that. And then let's say div like so, and then we're going to say, let's say we're gonna say age like so, and then we're gonna say age like so, because we're gonna create a function component from React, function component iProps like so, and now we have a dependency, and this means that our container isn't going to be all that, or rather we're not going to be happy up here, because we're actually not passing in anything. Our interfaces are now misaligned because we're not passing anything, and we're going to fix that. Don't worry, don't you worry. Map state to props. So we're going to create a function that is going to return an object, and this function takes in the state. Let's do this. And let's call that any. And let's say age state dot app dot age. Everything's peachy, and then we need to connect it. This is where React Redux comes into play. So you see Redux is a separate library from React Redux. There's a rumor, a vicious rumor out there on the internet saying that, oh, you need to have like you need to have React and Redux, and like Redux is connected to React. This is absolutely false. This whole thing would fall together without React Redux. That's why we have the connect function, because this is the thing that is actually hooking together the context API from React together with Redux, so that when Redux updates the state, React actually knows to re-render and pass new properties down through the chain or like the tree. So now we're going to change the init state, and we're going to say age, and we're going to say 1, 2, 3. Or 1 to 2, 2, 3, something like that. And here we are. So what's actually happening right now is that we have hooked this up to Redux. And the init state is passing through all these properties into the container, which is going to be handled here. And then we extract out the age from our app module, put that on our state that we're going to pass to the props, and our compose function, as we were saying, this is just creating another component around our component that is injecting that age property, and then it finally arrives down here. Now there is no on click, but we're going to sort that out. Don't you worry. So what we're going to do now is that we're going to declare const map dispatch, I believe, to props, and that's going to take a dispatch function, and let's just do dispatch any for now, And let's do that. Return on click, and that's a function that's going to say alert 1, like so. And this is the other thing. So now we have map dispatch to props, which is the other thing that is interesting here, because now we have an on-click function. And this I'm going to put over here, and then I'm going to create a button. And that is going to say click me. And on click, as you can probably imagine, I'm building up to something here. It's going to call the on click function. Amazing, right? So now when I click, it says 1. Amazing. I know. I hope you're writing all of this down. So now we have the full flow. So basically we have both a way to pass in our immutable state, and we also have a way of passing in functions and logic and stuff like that, which is going to get the dispatch function, which is the function that is responsible for communicating between our code and the Redux state. So in order to use this, we actually need to have something here in the reducer. So I'm going to create events.ts export enum app events, and we're going to say set age, and this is just a personal preference, but I like to say something like app slash, so I'm basically my convention is module name slash action, because that way you can namespace action, so you don't find like you might be wanting to set age in different modules and different Redux modules, and this is just a way to make sure that you're not colliding somewhere. And then we're going to say actions.ts, let's start say it like that, and then we're going to say const set age, which is going to be equal to a function that returns a type of event names app events, like so, set age, and then we're going to say payload. And payload is going to be a number, because that is the age that we are going to set age. And let's just kill off this, and then we're going to go over, where are we now? Here. We're going to say dispatch, and then we are going to say set age, and that's going to be in floor math.random, something just random like that, and age. We can change this any to iAction. Did I actually? No, I didn't actually declare that, so I'm going to just do this. Export interface, yes, iAction, because I like interfaces, which is going to take a type, which is going to be an app events, and then a payload of any. That's so great, right? And action, like so. So now we know what type of action we can dispatch here. What type of action can we dispatch? We can dispatch a type of iAction. So great. And if I now click things, nothing happens. And the reason why nothing happens is because I haven't added a case here, which is what I'm going to do now. App events.set age, like so, return state, and then I'm going to say age action.payload, like so, and I can also now actually type this to action, so I now know what I'm gonna get, which is exactly what I want. So if I click here, you see that I'm getting a bunch of different numbers, which is so great, but I'm still not really happy with this, because this is, I mean, we're using a type system. The purpose of a type system is to help us with compiler warnings and other stuff. And as long as the state is undeclared like this, that's not going to do now, is it? So we're going to say export interface iState, and we're going to say age number. Let's start by saying that. And that's going to be a state, and this is going to be a state. Everything is in a state. And then we now at least know that we're going to get in a state that holds this information, like there's just an age, right? Which is great. So we could leave it at this and say that we're done now, but I like to take this one further, because this is a little bit, yeah, it's still kind of good, but you know, this thing here, payload, is still a type of any, and I really want this to be type 2 and age like this. And the same thing goes for the return value here. It's not really declared. Like if I do this, I don't get a compiler warning because the compiler doesn't know that I'm trying to create a state. This is something that I want to fix, right? So what I want here is to fix the typing that is happening on this state, but there's also this problem up here where I have this state here, which also is a type of any. And I don't like that either, because then I don't really know if the shape of this changes, and I want compiler warnings because compilers are absolutely awesome, especially when you're using them in JavaScript. So what we're going to do now is that we are going to use some compiler magic, and we're going to say export I app state, and we're going to say return type, oh shit, I forgot, type, return type, and we're going to say reducers, like so. So let's see where first available is being, oh sorry, I forgot, type of reducers. I always forget that. I need to convert it to, this is a value, and I just want the type of this value instead. So what this return type helper is going to do for me, which is just part of the compiler interfaces, it's going to obtain the return type of a function type. In other words, what this now does is that it returns the shape of the return value of this function, which is going to be this application state. So when I combine all of these reducers together and I create these different Redux modules, this type here is going to represent the composition of all of those states. To make that crystal clear to you, I can now go here and I can say app state, and now I actually have the state here. It actually, because before I could do this. I could say apps, blah, 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 blah. You see, no compiler warning whatsoever. And as soon as I do this, compiler warning, yes. And I can say app and age, and I can feel secure in that my compiler is going to warn me and show me that these things that I'm doing are incorrect. So, and I mean, I just want to show off this little part here as well, which is so nice. I can actually do this. I can create another module. This just seems to happen to be the same module. Well, let's ignore that. And now I can say age2 is going to be state.app2 age. So it just automatically figures out that, oh shit, dude, you have an update here. You don't have to maintain this at all. Like, because some people, and I've seen this before, some people, they do use, they actually create their own interface. And I mean, I've been guilty of this as well, where I've created an interface myself that represents the app state like this. But this just takes care of it automatically. It's TypeScript magic. The good people at Microsoft have really done their homework. I absolutely love this. So let's move on to the final stage, which is the thing that I'm still a little bit unhappy about. So I'm unhappy about this interface here. One part is that I don't want to be that guy. I don't want to be this. I don't want to be him who does this, who copy pastes this, and then I go and I say, all right, I want to create another one, and I do this, and then I do that, and I say name is also going to be something, right? And now I've copy pasted two functions, and I have set name and I have set age, and then I have to go down to my reducer, and then I have to do this, and then I create this, set name, cool. You see, I still don't get a compiler warning. I could have missed this. And the compiler doesn't tell me anything because it doesn't actually know what I'm doing. So the first thing I want to fix here is that I want to make sure that this damn thing knows what state I'm trying to create. And the easy fix for this is actually just to do this. Kaboom. So what just happens now is that I'm strongly typing my return value to be a type of state. So if I say name, it's going to complain. And it's complaining because I don't have a name on my state. How do I fix this? Oh, I'm glad you asked. Name string, like so. And then I have to say that the name is going to be blank, like so. And now, if I try to create a property or if I misspell something, it's going to warn me, which I absolutely love. Great, right? And now the final thing that I'm a little bit annoyed at is that my payload is a type of any, because how do I know what my payload is? I mean, yeah, sure, I have typed these things here, so it's not like whenever I dispatch this thing here, I can be sure that set age, I mean, it's already saying here the payload needs to be a number. And the same thing's going to go if I say set name here. If I do this, it's going to tell me that, oh, set name. Well, I forgot to, oh shit, I forgot to update that. Because, see, this is another one of them mistakes that I make. String, because I'm a fallible human and I need my compiler to tell me when I'm fucking up. So now it complains and it says, hey, you know what, this is not a string. So let's go back to age. So I want to solve this, because this is the call site, but this is the receiver. And I mean, the receiver also wants to know that nothing changed. So the way that I fix this is by first and foremost removing all of this duplicity that I'm creating here. I don't want to do this, right? So what I usually do is that I create a higher order function called make action, and that's going to take a lambda function, or I'm going to add a few generics here. So I'm going to say t extends app events, and then it's going to take a type of p. And type is going to be a type of t, and then I'm going to be returning another function that is going to take the payload, which is going to be a type of p. I hope you see where I'm going with this. Return type and payload. Cool. So now I just created a higher order function. So what I want to do now is that I want to change this setName function to make action, and then I'm going to just pass in this, and then I'm going to pass in that, and I'm going to say that name is going to take a string. So what just happened is that I basically wrote the same, like I reduced down this extra boilerplate here where I'm copy pasting code down to this one liner here, but the result is the exact same thing. And I can do the same thing here, and I can say make action app events set age, and that's going to be a number, and it's going to take app events dot set name. No, not set name, it's going to be set age, and I see here that I've already made a mistake. Set name like so, which is so great. And if I look in my container, same interface. Cool, right? Still working, but this time payload, and it's the same result, right? It's just that now we're like reducing down the amount of code that we're writing, which is I actually really love. Finally, we still haven't solved this. This is still a problem, so let's fix that. Cool. So let's say interface. Let's call that string map. Let's call it that. And this is an interface where the property name, or the key, is it's a string, right? Yes, because that's what it is on an object, and it takes in a type of something, like so. And then I'm gonna say type any function, just whatever function. It could be any function, because this is the thing. These I don't know what's going to go into these functions. I don't really care when I'm declaring this. I just want to be able to capture that my container of things is going to just be a list of different functions. Like every property is going to be mapped to some function. So I need to create a function that takes anything. And I do this by using this little nice dot annotation. And then I'm saying any, and then I return, or I can just do this. And then I can return anything. So this represents a function that will take any amount of arguments of any type and return anything. So it could be whatever, right? And then I create this magical little compiler helper. So let's call that let's say I, because we want to be consistent. Interface for I for interface. I action union, like so. And this is also going to take a type, and let's say a. And that's going to extend my string map. So the input to this is going to be my string map. And that string map is going to take any function, because that's the value that I have here. I could have probably just strongly typed that if I explicitly said that that was the case. But I can do this instead as well. And then I'm going to go back to my old pal return type. And I'm going to say, I want you to give me the return value of whatever is a key of, or a key of A. So what I'm basically saying here is that, hey, you know what? I have this magical function, this type declaration here. It's going to take a generic that is an extension of iStringMap. Well, basically, it's just going to be string map in this case. And that's going to contain any function. Like, it's just a map where, okay, it's basically the same thing as saying, hey, I have an object here with a bunch of properties and a bunch of values, and the values are always going to be a function that can do anything, which is this thing here. And then thanks to my compiler helper return type, I'm going to say obtain the return type of the function type. In other words, I'm strictly typing this as well. I'm saying that, all right, grab all the things like the values or the return value of all the keys of A. In other words, it basically goes through the object that holds all of these different functions and checks the function that I have declared in that object and checks the return value. So now I need to do one more thing to get this to work. And that is to say const actions and create an object. Yes, set name, and then I'm going to set age, like so. How nice is that? And now, if I remove my iActions interface and I create another one, type iAction, like so, and then I say iAction union, and then I say type of, because I want the type of my object here, actions, I have achieved the same result as we saw on the state. So here, I now have a union type. So this is the thing that I used to be a barbarian and I used to write by hand, where I just do that little pipe you see there that just concatenates the types of all possible actions, right? And thanks to the fact that the compiler now knows that the type is different, so I have one type which is going to be set name and one type that is set age, and I know that the payload is string in one case and number in the other, I can go back to my reducer, and my reducer now knows that this is not going to work because payload is a string, and that is because the value here is set name, and because as if we go back here, the declaration here, as you can see, it knows that if the type is set name, the payload is a string. If the type is set age, the payload is a number. And I don't have to do any boilerplate. This is just magically now taking care of itself, which is so nice. So hopefully this is basically how I set up TypeScript with Redux, and at the same time I maintain type safety across pretty much the whole application. I don't think that I've missed anything, but if I have, just let me know. But this is pretty much it. So now my container is type safe here. My actions are all type safe, and I don't have to do unnecessary coding. I just have a higher order function that just works like this. There's no boilerplate, or very little at least. And then my reducer is also type safe. And the best part, which is we're just gonna look at that one more time. The total application state, the whole thing, is taken care of thanks to this little magical helper return type. So say thank you to all the nice people who maintain TypeScript at Microsoft, and have a great day.